Dear colleagues, my name is Michal Ordak and I'm an assistant professor at the Medical University of Warsaw and a statistical editor for Allergy. Together with the other members of the IACI Methodology Committee and the other co-authors, we published a review article on statistical analysis in allergy and immunology, focusing on practical examples from both fields. Clear and transparent reporting of statistical methods is essential for credible and reproducible research, including explicit alignment of analysis with the research question and clear statement of each test's purpose. Well-documented analyses show how conclusions were reached, allow validity to be judged, and support replication with justified and documented variable selection, use of appropriate descriptive statistics, and transparent handling of missing data. Precise definitions and correct terminology prevent misinterpretation and ensure coherence with the research question and should be accompanied by references to methodological sources and tools. Because most mistakes come from basic errors, guidelines such as consort, strobe, and sample are vital for improving statistical reporting. Assumptions in statistical tests must be verified to ensure valid results. This includes checking normality and variance homogeneity, selecting appropriate tests, and using corrections or robust alternatives if assumptions fail. In large samples, normality tests play a minor role, so the focus shifts to variance structure and independence. Assumption checks should also address outliers and match methods to the measurement scale, as these affect choices and interpretation. Finally, adapting methods to small samples or non-normal data with transparent reporting supports accuracy, robustness, and reproducibility. Assumptions are critical not only in simple tests but also in regression and advanced analysis, where careful evaluation is essential for valid inference. Transparent variable selection should align modeling with study goals and data structure, while accounting for non-linearity and interactions prevents residual confounding. Avoiding arbitrary categorization of continuous variables preserves variability and precision, and causal diagrams with structured confounding control support valid inference. Robust standard errors help when assumptions are imperfect, and explicit modeling of effect modification improves interpretation. Addressing autocorrelation and outliers is key for valid estimates in longitudinal or extreme data, while in meta-analysis justified model choice ensures relevance and avoids data-driven bias. Finally, comprehensive reporting of heterogeneity across studies strengthens credibility. Advanced methods such as Mendelian randomization, missing data analysis, or regression models also require explicit testing of assumptions, while exploratory techniques like clustering or PCA demand transparency and robustness checks due to their sensitivity to methodological choices. Statistical significance does not necessarily equal clinical importance. To improve interpretation, we should report effect sizes alongside p-values and use them for both categorical and continuous data. Even in non-parametric analysis, effect size measures add valuable context. Most importantly, incorporating minimal clinically important differences helps ensure results are not only statistically significant but also meaningful for patients and decision making. This is important because p-values can be misleading. Namely, in very large studies, statistical tests may show that even tiny differences without clinical importance are statistically significant, while in very small studies, clinically important effects may not be detected as statistically significant. Effect sizes show how substantial an effect really is, and minimal clinically important differences indicate the smallest change that patients perceive as meaningful, linking those numbers to outcomes that matter for both patients and clinicians. Summarizing robust statistical methodology is vital for valid, reproducible, and clinically meaningful results in allergy and immunology. Priorities include transparent reporting, assumption checking, and interpretation beyond p-values, supported by effect sizes and clinical thresholds. Clear documentation of analytical choices and alignment with study design strengthens credibility and communication with clinical audiences. Ultimately, advancing statistical rigor and transparency will improve research quality and support better decision making in clinical and public health. Thank you very much.